Okay, this is part 2 of a 2-part series, and actually part 2 should come first. I'm going to introduce you to my system, give you an idea of how it was made. This is an imbert type system. It's sealed on the top. I think it's far more superior to the FEMA system, because the FEMA system, the fire seems to migrate up and down the can. You have a lot of gas fluctuation. Sometimes your engine will go out. It wasn't a good system. So I switched to the imbert system. I've used some car weather stripping, put it around the drum here. I've lined the lid with a little bit of silicone, so we have a nice tight fit. What I like to do is I like to keep this oiled up with some synthetic oil, and it gives a little tighter fit, a little better seal. I close this up. I have another gate that comes over top of this gate. I put a chip in between, and then what I do is I just bolt it down. The whole system is sealed. No air gets in through the top. I tried to put a glass door on the top, but it just gets too dirtied up. But that's all sealed. No air gets in through there. If you're making a door, it was not a good idea to make a door. I'd use a pipe like you see on the internet. You use a large clean-out pipe, but I didn't have access to a pipe, so I did make a door. It did leak, so I ended up having to braid some flat bar across it and bolt them, and I don't have a problem with any leaking down there. I did the same thing to the bottom. What I did was I used a 45-gallon drum from my chip holding container, and it holds 80 pounds of chips. I used a propane tank from my center tube that goes down and into my hearth, and the hearth, the restriction is 120 millimeters. And what I did was I just cut a bunch of slits in my propane, and then hammered them all in, and then welded it up at about 120 millimeters. I fabricated the bell out of some sheet metal, and my bell is about 6 inches long, and basically goes out quite a ways and then into my grate, and that all comes down about 2/3 of the way, and my grate is attached through the bottom. I made myself a turning handle just in case my charcoal built up too much in the grate, so I could basically shake the grate, but I haven't had to use it because I have a shaker built onto the system. I probably got enough room from here down to hold about 5 or 6 hours of running time on my system. For shaking, I used an old washing machine motor. I put a threaded piece of ready rod on here, heavier on this side than this side. I just want to give enough shake to keep the blocks moving down through the drum so I don't get any bridging, and also enough shake that my charcoal will fall between my grate so it doesn't get plugged up. I could put a nut on here and wind in or out if I wanted more shake to happen. That just runs off my normal house 110. I built myself a cyclone. I don't have a cone in the bottom, but the pipe going in offset causes a swirl, and then the leftover gas comes out the top. Even though I don't have a cone in the bottom, it should work the same way, and I've noticed a lot cleaner gas coming out since I put this cyclone system in. All this stuff was built out of drums and water tanks that I found at the dump. Just to go back on this, all these pipes, or these air tubes, go down, and they go actually into my propane tank just above where I want the fire to be burning. And this pulls all the air out from inside the hearth. So these tubes go into my hearth, kind of like a down and angled in, all welded into the hearth, going through the hearth, so the gas only moves out from the bottom of the hearth and out to this pipe. This is flex pipe. I probably get a little bit of after the air has come through here. You don't want any other oxygen or any air coming into this can except through here, nowhere else. Once it gets past here and starts running down the line, You can have a few little leaks here and there. It'll just mix in with your regular gas and makes it a little more, it makes it able to ignite. It has to be mixed with some air further down the line before it goes into the motor anyways. All this line aids, and also this cyclone aids in cooling everything as it gets further down the line. This drum is worth a couple of pipes in cooling for dissipation. If you figure out the surface units of this and my 3-inch 10-foot pipes, you'll find that this is worth a couple of pipes. It helps in cooling everything before it gets down to the motor. I got a small 3/16 orifice drilled in the bottom for letting out any condensate that has tar, and I had a little bit of charcoal coming out of there too originally before I put in my cyclone. More flex pipe, and I'm probably getting a little bit of air infiltration into the system. When I come up to here, there's a lightly packed fiberglass in this can, and it takes out the rest of the charcoal, and this can runs very cool, so I get a lot of condensate coming out of this this other hole that I drilled under here. The condensate that comes out of here is very clear. It's almost like tap water. So I think I've got all my tar and charcoal out of the system. This is my squirrel cage fan that I built out of an Aerostar heater fan, and I also have a small orifice drilled in the bottom of this. A couple little leaks around here, but not enough that it'll dilute the gas enough to stop the motor from working or stop it from firing properly. I started up on the battery here until I get some good smoke coming out of here. This used to be my my air regulator, so I could regulate how much air gets mixed with the gas for a proper burn, but it didn't work very well. Instead, what I did was I drilled a 3/4 inch orifice down here that I cover up with a little bit of tape depending on how much demand I need or how much load I put on the motor. It's usually covered about halfway to get a good engine start. I warm up the vehicle before I start. I warm up the vehicle first on gasoline. I warm it right up to about 70 degrees Celsius, and then I take out the fuel relay. The air going into my intake in this system is about 70 or 80 degrees, which is what's recommended. I've duct taped it into my intake, and it's pretty airtight. The system starts up right away, as you saw in part 1. Modifications that I did to this was I had a really hard time starting it because the ECU retards the timing when you press on the gas, and when it feels a load happening, the map sensor will retard the timing to combat any knock. So what I do is I unhook the throttle position sensor and the map sensor so that I don't have retarding of the timing. Wood gas is a slower burning gas, so in fact your timing actually has to be advanced, so any retardation of timing will give it a hard time starting. With these ECU run motors, you can't advance the timing, so you're pretty much stuck with what you got. So I just unhook those two sensors, throttle position sensor and a map sensor, so that it'll start properly and run half decently. My generator, which is a 40 kilowatt generator, is run right off the drive shaft. I took the yoke off of the rear end over there, and welded it to the drive shaft of the generator. It took me quite a while to get that all set up. I used squares and micrometers and stuff, and still it was a little bit off. So I balanced it with a muffler clamp, and I put a nut in between to get it finely tuned, fine-tuned balance, and it runs at 1800 RPM, and it runs nice and smooth. This ties into my transmission, straight on my drive shaft. You'd think that I'd be able to set my cruise control, but there's not enough load or not enough what you call flywheel type motion to keep it steady like it would on the highway, so I end up having a lot of fluctuation in the speed, and it ends up going out of its parameters and then shutting down the cruise control. So I've got a primitive way of setting up my throttle. Until I got something else set up, I just kind of get this all set up back. So I'm running at about 65 kilometers an hour, which is about 1800 RPM. That's my whole system in a nutshell. Very important when you build this system that your gasifier is airtight, except for the air coming into the tubes. Even though I was careful to begin with, I still had air infiltration. My trap doors are sealed with asbestos rope. This looks a little hokey, but is all overlapping, and no air is getting in there. The asbestos rope seems to handle the heat for a few runs, depending on how many times you open and close the door. But I use muffler cement to hold that in place, and it's the can is a little hot for the muffler cement. It tends to break down pretty quick, so you have to kind of re-glue that, put some more asbestos rope on occasionally. My chips, I think the best size to use is between 2 and 3 cubic inches. I went out and I cut a few 2-inch slabs, and I chopped them down by hand, and I can usually do about between 60 and 80 pounds in an hour. It would be great for an emergency, but it's pretty labor intensive if you're going to run your house off of this and run it all day. You pretty much got a steady job chopping. So this is where I chopped up all my chips. My system tends to go through about 40 pounds in an hour, running at 8.4 kilowatts, which is quite a bit. Really, I shouldn't be going through any more than about 25 pounds in an hour. But I think that the inefficiency and the usage of chips comes from too big of a generator for what I'm pulling, probably too big a horsepower motor for what I'm pulling, so you don't have proper sizing for the use. And that's my whole system in a big nutshell.